Back to the basic. Mathematics. Introduction to Statistics. The statistics. The statistics is the science of data, starting from data collection to its presentation. It provides the analysis of data in useful manner. The average. The data and the average. The mean, the mode, the median. The data display, the graph chart, the histogram, the bar chart, the pie chart, the scatter diagram. Dispersion of data set. We talk about the range, the quartile, the percentile, the variance, the standard deviation. The statistics. The statistics makes us learn how best is the data can be presented and displayed numerically in tabular form or in graphic form. Interpretation of data in most useful form, both scientifically or economically, in public domain. The data. The data are the fact and figure. Data may be classified as either quantitative or qualitative. The quantitative data. The quantitative data means the data that measures something, either in how much or in how many. It is generally expressed in numbers and numbers of unit. For example, length of a cloth is a quantity in meters. Weight and height of a boy. Temperature of the morning in degrees Celsius. The qualitative data. Qualitative data provide label or name for categories of like items. Qualitative data express something without any number. For example, the cloth is blue. The boy is tall. Today is a sunny day. Ethnic community. The sources of data. The sources of data are the surveys, the records of institutes or business houses, the measurements, the results of experiments and observations. Surveys is an investigation of collecting information and data. Survey design could be either sample survey or 100% like we do in census. The surveys are carried out in field by observations and by interviews of the public, generally by governments, market researcher, or trade organization. The data is also available from the records of institutes or business houses, the records of employees in a factory, the records of students in a school. These data are generally recorded at the time of entry and upgraded time to time. The performance data from records of a company or schools. Some of these data need dynamic analysis. Scientific data come in form of measurements, results of experiments, and observations. Data presentation and display. These are done by tabular method and graphic method. The data comes in various form and categories, such as raw data, the data that are arranged and ordered data, raw data that are ungrouped and grouped data, the data along with frequency, data that are divided in class and in interval, the data that focuses at midpoint of class intervals, the data with its cumulative frequency. Data for inspection. The data can be shown nicely either in tabular form or can be displayed in graphic form. When we deal with a set of data which has more than 5 to 6 in numbers, or it contains big numbers, we need to put them either in tabular form or in graphic display. The inspection of data is easier if the data are put in a table in increasing order or in decreasing order. From such tables, it is easier to find the mode, the median and the assumed mean, which we will discuss in detail shortly. The tabular methods. The set of data are put in table with certain classification. The table of data may be either in increasing order or in decreasing order. The data value with its frequency distributions. The most commonly tabular summary of data for a single variable is a frequency distribution. It shows the number of data values in each of several non-overlapping classes. The raw data. When the data are first collected, they are neither in any order nor in any presentable form. These data are called raw data. Here is a set of test marks of 100 students of a class out of 10 marks. Graphic display of raw data. Ungrouped data. When the data are collected, they are neither in any order nor form any group. This set of data is ungrouped data. Such data does not convey any information straightway. Ungrouped data, shown by bar chart. Data presentation by tabular method. The raw data. These raw data, or ungrouped data, do not convey any impression or meaningful information, specially if number of data or values are more than 5, 6. First thing we do to put the data in order of increasing number or value. Table of ordered data. Now, rewrite the data in increasing order. The data are arranged and ordered. We can note some marks are repeatedly appeared more than once. Number of times the data appeared is its frequency. Note here, the frequency of marks 10 is 3. Graphic display of the data in order. Mark the difference in graphic display. Compare to last. We saw with raw data. Now, we will show you same data in bar chart presentation. Such tables of ordered data and graphical displays help us inspecting data in some useful manner. We can see now the mode and the assumed mean of the data. Frequency distribution. Number of times a data appeared is its frequency. A table below for frequency distribution shows the frequency of repeated marks in a tabular form. It gives a visual display of the frequency of items and shows the number of times they occurred. Frequency distribution. The frequency distribution is used to organize the collected data in table form. The data could be marks scored by students, temperatures of different towns, or any other data. After the data collection, we show the data in a meaningful manner for better understanding, organizing the data in such a way that all its features are summarized in a table. This is known as frequency distribution. Group data. In performance report, the teacher divides the results of marking into 5 classes or groups as 0 to 2 marks as very poor, 3 to 4 marks as poor, 5 to 6 marks as average, 7 to 8 marks as better, and 9 to 10 marks as outstanding. Table of group data. Marks groups versus number of students. 0 to 2, 5. 3 to 4, 8. 5 to 6, 32. 7 to 8, 42. And 9 to 10, 13. To understand clearly, we take another set of data already available in grouped form in the table. The frequency distribution of marks of an examinations of 120 students out of 100 are given. Each mark is a whole number. The cumulative frequency. In statistic, a frequency means the number of times a value occurs. A cumulative frequency means the number of times a value less than to a stated value occurs. Or, the cumulative frequency means the number of times a value less than or equal to a stated value occurs in some data. Cumulative frequency table can be made from a frequency table. The cumulative frequency for any class is the sum of the frequencies of that class and all the lower classes The format of the table for less than group of data is shown here. First column is value, second column is frequency f, and third column is cumulative frequency cf. Note in cumulative frequency column the frequency fx of successive rows are added to previous cumulative frequency cf. As cf equals fx plus fxx, and frequency fxxx of third row is added, cf equals fx plus fxx plus fxxx, and so on. The easiest way to work this out to add successive frequency to give running total cumulative frequency CF in two type of value of data table. Classification: Table 1 less than, Table 2 less than and equal to. Cumulative frequency table can be made from a frequency table. Note how it is done. We have a frequency table shown here. Now we will add frequency in row to previous cumulative frequency and make running total. So it starts from 0 and goes on to 2, 5, 8, 13, and 13 plus 12 is equal to 25. 25 plus 20 is equal to 45, and so on. We reach to sum of all frequencies 100. Table of set of data with relative frequency distribution. In the table, the relative frequency distributions shows a fraction or percentage of data in each class out of total 1 or 100. Using same frequency table, here we shows relative frequency distribution. Tables for two or more variables. Two or more variables analog of a frequency distribution. A common tabular summary of data for two or more variables is a cross-tabulation, as shown here, where data of boys and girls, age, weight, and height are recorded at same time in different column. Table of raw data of two variables. The height and weight of 10 men are given in the table. Such table is important to see the relation of two variables and their dependency on each other. By analyzing, we can see how weight is related to the height. Data presentation by graphic methods. The frequency curve or graph. A frequency curve or graph can be drawn from the frequency table. On the graph, range of value is always on horizontal axis, and the cumulative frequencies on the vertical axis. Going back to frequency distribution data and working with same data of marks of 100 students as shown in the table, we will make graphic presentation. Here is marks distribution and its frequency graph. The cumulative frequency graph. A cumulative frequency graph, or curve, can be drawn from the frequency distribution table. On the graph, range of value is always on horizontal axis, and the cumulative frequencies on the vertical axis. Working with same data of marks of 100 students, as discussed earlier, we will plot the graph for the cumulative frequencies. See here, cumulative frequency curve, along with the set of data. Cumulative frequency curves. Note the difference between polygons and smooth curves. Cumulative frequency polygon. Here the data points are joined by straight lines, while in cumulative frequency curves, note that cumulative frequency curves means a smooth line joins the data points. We will draw both the polygon and, later, the curve of same set of data. Observe them carefully. The cumulative frequency curve. To understand further, we take another set of data in grouped form, the frequency distribution of marks of an examinations of 120 student. Out of 100, marks are grouped in the interval of 10 marks. With this data of marks of 120 students, we plot a graph of both frequency curve and cumulative frequency curve simultaneously. First, we draw polygon form, and later we will draw curve with smooth line. Here we see the polygon override the curve. Do you see any difference between the two? Yes, it does make a difference when we calculate some figure from the graphics format of data. Data displayed on histograms. The histograms. Histograms are often used to show group data. This gives you a clear picture of the data and any pattern that exists. A histogram uses bars to show data, like in any XY graph in histogram 2. Both axes display numbers related to set of data. See here a histogram that shows a Marx frequency. Please note, height of the bar here is related to the frequency of each data. Histograms are often used to show group data. Whenever we deal with a lots of data, it is better and useful to put the data into the group of classes. The height of the bar in the histogram is related to the value, like in any XY graph. In histogram 2, both axes show numbers related to set of data. Area of the bar in the histogram, area of bar represents the frequency. Histogram of group data from the data of the students. As we discussed them earlier, the performance of the students is divided into 5 groups. As below, we draw a histogram from this set of data. Histograms are often used to show group data. The range of possible value which can be put into each group is called class interval. A frequency table, just like a tally table, show of item frequency for each group. The class boundaries for each group are smallest and largest value of an item in that class can have. Please observe carefully as we show you another histogram of another group of data. The width of the bar in a histogram represent the size of the class interval. So if the class interval is equal, then bars of the histogram are of equal width. The edge of each bar must be on the class boundary. For the group, the class boundary is usually halfway between upper limit of one class and lower limit of next class. Please practice as we draw a histogram from the data. A list of marks out of 100 gained by 36 boys in a test is given below a table. Arrange them first into class interval of 10 marks from 0 to 9, then 10 to 19, 20 to 29, and so on. Have you noticed? We had taken the class boundary as 9.5, 19.5, 29.5, and so on. Now we draw a histogram. Have you noticed? In second histogram, the class boundary are taken as 9.5, 19.5, 29.5, and so on. Here is a histogram of the data of the prices of the 25 calculators. 2 are at a price of $20, 6 at $24, 10 at $25, 4 at $30, and 3 at $32. The area of the bar represent the frequency, f times dx number of the item, as marked in the box above each bar. Pictorial presentation. The bar chart, the pie chart, the scatter diagram. Pictorial presentation of data. For effective and meaningful pictorial presentation of data, commonly used are the bar chart, the pie chart, and the scatter diagram. The bar chart. In a simple bar chart, the heights of the bars shows the frequency of the variable or the value. The bars are made generally vertically but can also be horizontal. Bar charts are very effective in making a comparison and give strong visual effects. We make a bar chart Bar chart is here for data of the quantity, numbers of 5 brands A, B, C, D, E of calculators. 2RA, 6RB, 10RC, 4RD, and 3RE. Bar chart of horizontally bars. Unlike histogram, the bar chart gives only simple information of numbers or value on one axis. Compound bar chart can be made when more values are there to compare from point to point or year-to-year basis. Here we make a compound bar chart of sale of items, TV, refrigerator, and washing machine in 3 years: 2021, 2022, 2023. See how easy to compare on first glance. The pie chart. A pie, circular, chart is a way to compare data. The whole pie, the circle area, shows the whole data. Each portion, a sector, a fraction, shows the data. The circle is divided into sectors. A fraction of angle out of 360 degrees in proportion to their value. The pie chart. To draw a pie chart, make a circle using a compass of bigger size and use protractor to draw angles of sectors. Vertex at the center of the circle from a horizontal or vertical line. Draw smallest angle first, then next smaller, the largest angle in last. Label each sector and angle carefully. Use different color to set a sector. We will make couple of pie charts here for practice. Pie chart of data of 24 calculators of 5 brands A, B, C, D, E. Brand A has 2 number of calculators, so it will be a sector of 30 degrees. Brand B has 6 number of calculators, so it will be a sector of 90 degrees. So brand C with 9 numbers have sector of 135 degrees. So brand D with 4 numbers have sector of 60 degrees. So brand E with 3 numbers have sector of 45 degrees. All 24 number of computers will add up sector angles to 360 degrees. Try to make another pie chart from the data given below. In a survey, 400 people were asked which Sunday paper they prefer to read. The number of people naming each paper was Sunday Time preferred by 75 people, News of the World by 150, Sunday Mirror by 100, The Observer by 50, Sunday Telegraph by 25. Draw a circle, which represent total angle 360 degrees, equivalent to total number of people is 400. Calculate sector angles for each data by multiplying by 360 divided by 400. Sector angle of Sunday time would be 75 divided by 400 times 360 degrees equals 67.5 degrees. Sector angle of news of the world, 150 divided by 400 times 360 degrees equals 135 degrees. Sector angle of Sunday mirror is 100 divided by 400 times 360 degrees equals 90 degrees. Sector angle of the observer is 50 divided by 400 times 360 degrees equals 45 degrees. Sector angle of Sunday telegram 25 divided by 400 times 360 degrees equals 22.5 degrees. Scatter diagram. Scatter diagram. Sometime, the data we collect has more than one variable or measurements. In a class you may collect the data of weight and height of each boys and girls, along with their age, in order to analyze the growth of each student relative to each other. The height and the weight of 10 men are given in the table. Use the grid or graph paper to plot the data on a scatter diagram and draw a line. Best fit of these points from the line suggest the man's similar body frame, his possible height for a weight of 73 kilograms. We draw another scatter diagram, this time on a revised scale of axes, for better accuracy. From observation of average, the best line to suggest that the man of height 177 centimeters will have weight of 73 kilograms. The averages an average is a measure of central location, a value around which the set of data is. An average is a measure of location which provides an indication of the position of the data. An average summarizes a group of data and provides immediate idea about a group. An average describes data concisely. Average is something we observe or analyze first to describe how a set of data is distributed. For example, the distribution of weight of 2,000 people could be described by a value representative of most of these weight. An average value, or middle value, or more common value, together with an indication of how far the weight are spread about this value. The most commonly used averages are the arithmetic mean, a sum of all values divided by number of value. The median, the value of middle item. The mode, most frequently occurring value. The geometric mean, nth root of the product of the values. The average, the mean. The mean or the arithmetic mean. What is the mean of set of data? 1, 2, 3. It is 2. If 3 men earn daily $400, $450, and $350 respectively. By observing, we can say the average earning is $400. Or we talk about what is the mean value of set of numbers 11, 12, 13, 14, and 15. It is easier to say it is 13. However, if numbers are random in order, say 13, 15, 14, 11, 12, it will be better we calculate it. If a set of numbers is 4, 6, 5, 8, 9, 12, the numbers are neither in order nor at equal interval. To find the mean, we need to do some calculation. To calculate the mean, we follow the formula. That is, a mean of a set of n numbers is the sum of all the numbers divided by n. The mean of 6 numbers 4, 6, 5, 8, 9, and 12 is the sum of 4 plus 6 plus 5 plus 8 plus 9 plus 12 is equal to 44. Then divided by 6 is 44 divided by 6 is equal to 7.333. Similarly, the mean of 5 numbers 13, 15, 14, 11 and 12 is the sum of 13 plus 15 plus 14 plus 11 plus 12 is equal to 65. Is 65 divided by 5 is equal to 13. Generalizing a formula of a mean for a set of n number x1, x2, x3, up to xn. The mean of a set of n numbers is the sum of all the numbers x1 plus x2 plus x3 dash plus plus up to xn, denoted as capital sigma, divided by n. The mean bar is the sum of the numbers sigma sigma divided by n bar sad face sigma underscore divided by. Remember, capital sigma stand for sum of. The mean is generally denoted by x bar. Mean of raw data. When the data are first collected, they are raw. The mean of these raw data is the mean bar sigma xi divided by n equals, or 648 divided by 100 equals 6.48. We show you mean of raw data on a graphic chart and draw a line of average. This line shows the mean around all data points and deviation of data point from the average. Calculating mean by assuming mean method. By inspection of data set. First assume a mean, then work out the deviation dx of each data from assumed mean x. Now calculate mean of all deviation 1 divided by n times sigma dx. Finally add or subtract the mean deviation from assumed mean. That will give you true mean of the set of numbers. Try this method with a set of 5 numbers that are 215, 217, 228, 220, and 230. Assume a mean x. By inspecting data, it is assumed as 220. Calculating mean by assuming mean x equals 220. For a set of 5 numbers are 215, 217, 228, 220, and 230. The deviations dx from assumed mean are minus 5, that 215 minus 220, minus 3, 8, 0, and 10. The mean of all deviations equals 10 divided by 5 equals 2. Therefore bar equals x plus or minus dx equals 222. Formula for calculating mean by assuming mean. First assume a mean x by inspection and calculate deviation dx, value minus from assumed mean, for each data. Formula would be, for the mean of all data, x bar is assumed mean value x plus the sum of the deviations sigma dx divided by n, or bar equals plus sigma dx divided by n. The advantages of assuming mean methods is to reduce and to simplify the calculation for a set of data of large and big numbers. Method of calculating mean by assuming mean method. X bar equals x plus sigma dx divided by n. For example, 5 people earn 315, 320, 330, 350 and 360. Calculate the mean by assuming a mean method. Note in table. Assume the mean x may be taken as 330. Deviations from assumed mean x equals 330 is minus 15, minus 10, 0, 20, 30. So the sum of deviation minus 25 plus 50 is equal to 25. So the mean x bar is 330 plus 25 divided by 5 is equal to 335. Method of calculating mean for a frequency distribution. When the data is available in frequency distribution, we can calculate arithmetic mean of the group data by a formula. The mean x bar is calculated by multiplying the value by its frequency, the sum of the product, that is, sigma f times x, and divided it by sum of the frequencies sigma f. Therefore, x bar equals sigma f times x divided by sigma f. We explain with an example. Mean for a frequency distribution. Calculating mean for a frequency distribution. For example, 25 calculators in a shop have following prices. 2 are at a price of $20, 6 at $24, 10 at $25, 4 at $30, and 3 at $32. We put the number of calculator frequency f in the table, and price times frequency f times x, 40, 144, 250, 120, 96. Total of all frequency 25, and sum of all product 650. Therefore, x bar equals 650 divided by 25 equals $26. Mean from histogram of same data of the prices of 25 calculators. You may get the idea how histogram can help you understand. Histogram can shows area of the bar representing f times x. Total of all frequency 25, and sum of all product 650. Therefore, x bar equals 650 divided by 25 equals $26. Calculating mean by assumed mean x. For a frequency distribution, assume a mean first by observing the data set. For the data in frequency distribution, the mean x bar is calculated by multiplying the deviation dx of value from assumed mean x by its frequency, and sum of the product. Sigma f times dx and divided by sum of the frequencies. Sigma f. This value is then added or subtracted to assumed mean. Therefore the mean x bar equals x plus or minus sigma f times dx divided by sigma f. We will explain it by a numerical example. Calculate the mean price of 25 phones of different brand in a shop, which has 2 are at the price of $320, 6 at $330, 10 at $350, 4 at $380, 3 at $450. By inspection it is assumed a mean price of $350. In the table we first calculate deviations from assumed mean dx for each data value. -30, -20, 0, 30, and 100. And also calculate deviation times frequency for each data value. -60, -120, 0, 120 and 300. Sum of all frequency equals 25 and sum of all product f times dx equals 240. Therefore the mean x bar equals x plus or minus sigma f times dx divided by sigma f equals 350 plus 240 divided by 25 equals 350 plus 9.6 equals $359.6. Method of calculating mean for a grouped frequency distribution. Frequency are grouped within class interval. Consider the midpoint of class interval method. First, note down the mid of all class intervals. Also we will take midpoint as assumed mean from the suitable class. The mean x bar is calculated by multiplying the deviation dx of midpoint of the class value from the assumed midpoint mean x by its frequency, sum of the product sigma f dx and divided by sum of the frequencies sigma f. This value is then added or subtracted to assume midpoint mean. Therefore, x bar equals x plus or minus sigma f dx divided by sigma f. For midpoint method, we explain with an example. Here in the table, overtime of employee are given in pound. In the class interval of £5, we choose 35 to 40 class and at midpoint 37.5 as assumed mean. Note down the number of employee, frequency f for each class, and midpoint of class interval 22.5, 27.5.32.5, 37.5, 42.5, 47.5. Now the deviations of midpoints from assumed mean 37.5, -15, -10, -5, 0, 5, 10. And price times frequency f times x -165, -150, -80, 0, 150, 100. Sum of all frequency equals 100. And sum of all product f times dx equals -145. Therefore the mean x bar equals x plus or minus sigma f times dx divided by sigma f equals 37.5 minus 145 divided by 100 equals £36.05. Method of calculating for a grouped frequency distribution using same frequency distribution in class interval by another different method known as class intervals method. Note here, we chose best class for the assumed mean, and midpoint of that class is assumed mean. Therefore, the mean bar is calculated by multiplying the deviation dx of the class from assumed class of midpoint mean x by its frequency. Sum of the product sigma f dx is then divided by sum of the frequencies sigma f. This value is then added or subtracted to assumed midpoint mean. X bar equals x plus or minus sigma f dx and divided by sigma f times class interval. Here in the table, overtime of employee are given in pound. In the class interval of £5, we choose 35 to 40 class and at midpoint 37.5 as assumed mean. Note down the number of employee frequency f for each class. Now the deviations of class from assumed class 35 to 40, minus 3, minus 2, minus 1, 0, 1, 2, and frequency times deviation f times x, minus 33, minus 30, minus 16, 0, 30, 20. Sum of all frequency equals 100, and sum of all product f times dx equals minus 29. Therefore the mean x bar equals x plus or minus sigma f times dx divided by sigma f times class interval equals 37.5 minus 29 divided by 100 times 5 is equal to 37.5 minus 1.45 equals £36.05. Method of calculating mean for a grouped frequency distribution in uneven class interval. Uneven class intervals method. The mean x bar is calculated by multiplying the deviation dx of midpoint of the class value from assumed midpoint mean x by its frequency, sum of the product sigma f dx and divided by sum of the frequencies sigma f. This value is then added or subtracted to assumed midpoint mean. X bar equals x plus or minus sigma f dx and divided by sigma f times class interval. It is better explained by taking one numerical example. Here in the table, overtime of employee are given in UN even class. In the class interval of £10, we choose 60 to 70 class and at midpoint 65 as assumed mean. Note down the number of employee frequency f for each class. Note uneven class from 80 to 100, which is combined as 80 to 90 and 90 to 100. Now the deviations of class from assumed class 60 to 70, minus 2, minus 1, 0, 1, 2.5. It is a men of 2 and 3. And frequency times deviation f times x, minus 20, minus 14, 0, 6, 10. Sum of all frequency equals 50, and sum of all product f times dx equals minus 18. Therefore the mean x bar equals x plus or minus sigma f times d x divided by sigma f times class interval equals 65 minus 18 divided by 50 times 10 is equal to 60 minus 3.6 equals 61.4 pounds. Weighted mean. We explain it by example. If a boy scored 20 and 30 marks in 2 exams, the average mean is 25. But if first exam is twice as long as second, it would be fair to weigh it by a factor of 2. The weighted mean x bar would be equals 20 times 2 plus 30 times 1 divided by 2 plus 1 equals 70 divided by 3 equals 23.1 divided by 3. Note we always divide by sum of the weighting. Consider again. If a boy scored 20 and 30 marks in 2 exams, the average mean is 25. If first exam in English and second in maths, then for some purpose, mathematics might be considered twice as important as English. This time the weighted mean x bar equals 20 times 1 plus 30 times 2 divided by 2 plus 1 equals 80 divided by 3 equals 26.2 divided by 3. Note we always divide by sum of the weighting. Moving mean. Some quantities, such as share price, unemployment, trade figure, vary considerably. For better indication of trend, we take average over certain time period of time, rather average of entire period. If the period varies, we call it moving average. Figure below shows number of unemployed in some holiday resort. If the period varies, we call it moving average. Figure shows number of unemployed in some holiday resort as March 84, April 50, May 64, June 53, July 45 and August 21. Moving mean of March to May equals 84 plus 50 plus 64 divided by 3 equals 66. Moving mean of April to June equals 50 plus 64 plus 53 divided by 3 equals 55 and 2/3. The average, the median, the median, the value of middle item, or midpoint, is the median of the data set when number are arranged in order of size. The median is the number in the middle. If there are 9 numbers, fifth is the middle number. It can be found by using a relation like 1/2, 9 plus 1 equals 5. If number are 12, then the median is the value halfway between 2 middle values. That mean Value of 6th and 7th value. In a discrete distribution, median can be found by observation. If the earning of 5 people are 60, 70, 100, 115 and 215, the middle item is 100. Therefore, the median equals 100. Formula for mid number is simple. Use 1/2 n plus 1 when n is odd number. And when number is even, then the median is the value halfway between two middle values that mean between 1/2 n value and 1/2 n plus 1 value. If the earning of 6 people are 60, 70, 100, 110, 155 and 215, median is halfway or equals 1/2. 100 plus 110 equals 105. Example: 60 drivers were asked how many accidents they had in last 5 years. The answer of drivers are given in this frequency table. Number of accidents, number of drivers: 0, 17 drivers, 1, 13 drivers, 2, 21 drivers, and so on. We show you the data in histogram along with cumulative frequency. That is 17, 30, 51, up to 2 accident, 55, up to 3 accidents, 57, up to 4 accidents, 59 and 60. For 5 and 6 accidents. As there are 60 drivers in the survey, the median is the mean of the 30th and 31st drivers. Number of accidents. From the table, 30th driver had 1 accident and 31st driver had 2. So, the median number of accident is 1 plus 2 divided by 2 equals 1.5. Calculation of the median with grouped frequency distribution. 2 methods are generally used. First by calculations. Second for approximate value by graphically. The median or middle position m for a continuous series is n divided by 2, or half of the cumulative frequency, f divided by 2. We will follow an example to understand it better. In the example, the weekly overtime earning of 50 employees are distributed from $0 to 30. Earning is divided into groups of 5. Weekly overtime of 50 employees divided into class of $5. Note in the table 2 middle groups, 10 to 15 and 15 to 20. But it is 15 to 20 group, where half of the frequency 25 will fall. We noticed a typing mistake instead of less than symbol. The more than symbol is typed in the table. So after studying the table again carefully, we find the mid-per is in 15 to 20 group. Overtime of 25th person is the median pay. 25th person is in group 15 to 20. 12 people earn $15 to 20. If we evenly distribute the earning of $5 in 12 person, the incremental increase per person, it would be $5 divided by 12 per person. In this class, 25th person is at 3rd place in this class, as it start from 23rd person. 23rd person will get $15 plus 5 divided by 12. 24th person will get $15 plus 2 times 5 divided by 12, and 25th person will get $15 plus 3 times 5 divided by 12 equals 15 plus 5 divided by 4 is equal to 16.25. So the median payment is equals $16.25. Median from graph. Cumulative frequency curve can be used to estimate the median. To estimate the median marks the halfway point on the cumulative frequency axis for n values. This point is at cumulative frequency of 1/2 n plus 1 or 1/2 n, and if n is large, it is 1/2 n. Here it is shown graphically by taking same example just used to calculate. On the graph, we marked the line on the y-axis at 25 and found on the x-axis. It is almost same as $16.30. We take another example. This data set is already discussed earlier. We use it now to get the median. And note how the median is drawn from the graph. To confirm by calculation, mean of mark of 60th and 61st person is the median marks. 60th person is in group 61 to 70. In this class, 35 students get marks between 61 and 70. If we evenly distribute 10 marks in 35 students, the incremental increase per student would be 10 divided by 35 per student. Note 60th student is at 11th place in this class, as it starts from 50th student. 60th student will get 60 plus 11 times 10 divided by 35 is equal to 63.14. 61st student will get 60 plus 12 times 10 divided by 35 is equal to 63.42. Mean of 2 equals 63.28. This is similar to what we had from the graph. Therefore median marks equals 63.28. The average. The mode. The mode. The mode is a kind of average that gives the number which occurs most often in a set of data. Calculation of the mode. The mode is the most frequently occurring value in a distribution. In a discrete distribution, the mode can be ascertained by inspection. For example, the mode of a set of data 4, 4, 5, 6, 6, 6, 6, 11, 11. Mode is 6 because it is most frequently occurring. Number. In a frequency distribution, the mode is the item with the highest frequency. For example, color of cars found in a town is shown in the table. The mode is white color car. 23 is the highest frequency. The mode shows maximum number of car are in white color. In a group frequency distribution, model class is the one with the highest frequency. For example, the weekly overtime pay of the 50 employee of a company is shown in the table. The model class is 10, but less than 15, because this class has the highest frequency. Now watch how mode is worked out graphically. The model marks is 7 in the test, as maximum of 25 students got this marks in the class. We take example of 60 drivers case again and see the mode from the table and from the histogram. From the table and from the histogram, the mode is very clearly visible as 2 number of accidents, as maximum numbers of drivers encountered it. We take another example of 25 calculators discussed earlier. Out of 25 calculators, maximum number of 10 calculators are at $25. So this is the mode or modal price value. These raw data we discussed earlier from observation. It is difficult to say about mode. Let's arrange it and put it on a graph sheet. From graphic clear the mark 7 is the mode mark. Dispersion of the data. The dispersion of a set of data is the spread of that data. It is an important factor. We learned so far. The sets of data are often compared by comparing their averages, the mean, the mode. Here in this graph, we show you spread of data around its average line in the center. The dispersion, the range. First observation of dispersion is the range. The range of a set of data is the difference between greatest and least value in that data. In this figure you see the range of two data sets. In this graph, you see the range of data set. The range is from 1 to 10. Dispersion in frequency distribution of data. It depends whether frequency distribution of data is symmetrical or skewed. Symmetrical frequency distribution is symmetric around its center. Skewed distribution can be of two types: positive skewed distribution, negative skewed distribution. Symmetrical frequency distribution is shown here. Note the mean, the median and the mode coincide at the same value. In skewed frequency distribution, if the peak or the mode in skewed distribution is on right side of the curve, it is called negative skewed distribution. Please note, here the mean and the median do not coincide. In skewed frequency distribution, if the peak or the mode in skewed distribution is on the left side, it is called positive skewed distribution. Please note, here the mean and the median do not coincide. It is possible that, in all three cases, you may find same mean. Dispersion. The interquartile range, the normal range we saw, is not very good measure of dispersion. Interquartile range. The interquartile range and semi-interquartile range are slightly better measure of dispersion than the range. It avoids the dominance of the extreme values at the both ends of the range. Let's see how quartile is defined and calculated. Percentiles. First, we tell you about the percentile. Cumulative frequency curve can be used to calculate the percentiles. Draw an extra axis on the right-hand side of the curve and mark 0 to 100. Each percentage point on the right-hand side axis represent a percentiles. The quartiles. Cumulative frequency curve with percentile can give the quartile. First quartile or lower quartile is 25 percentile. Second quartile or median is 50 percentile. Third quartile is upper quartile. It is 75 percentile. Interquartile range is the difference between upper quartile Q3, that is, the 3/4 n or 75 percentile value, and lower quartile Q1, that is the 1/4 n or 25 percentile value. The interquartile range is Q3 minus Q1. Semiquartile range. Semiquartile range is half of the interquartile range, equals 1/2 Q3 minus Q1. Here we show you interquartile range on the frequency distribution graph. The percentile. Percentile can be estimated from the cumulative frequency curve. To estimate percentile, we draw extra axis on the right-hand side of the curve and mark the from 0 to 100. 0 corresponds to 0 of cumulative frequency and 100 corresponds to total of all frequency or end of cumulative frequency n. Percentiles and percentage. The main difference between a percentage and a percentile is that a percentage means out of 100, a numerical value out of 100. The 75% is 75 out of 100. That is actually 3/4, while a percentile is a number that indicates the percentage data point or value that is equal to or less than a particular value. A 75 percentile point means all values at 75% and below 75%. A girl scores 90% in an exam. It simply means that she answers correctly 90 of 100 question of the exam paper. However, if she is told she scores in 90th percentile in the exam, it means that she scored marks better than 900 students out of 1,000 students, or better than 90% of all students who appeared in the exam. Note it on the curve the 90 percentile. You have seen on the curve the marks of 90 percentile. So note from the last displayed marks distribution curve, the 90 percentile student has scored marks between 71 and 80. It clearly shows that percentage and percentile are two different things. The percentage tell you how well you do in your exam, and the percentile tell you how good you are among your fellow students. Dispersion, the mean deviation. Another way to look at the dispersion of the data is the mean deviation. That is the arithmetic mean of the absolute difference of each value from the mean. See the table. The mean is 335. A column shows the difference as 20, 15, 5, 15, 25. Total of all difference is 80, which is divided by number data 5 to give the mean deviation 16. Mean deviation in frequency distribution can be calculated in similar fashion. Dispersion, standard deviation, dispersion of data around arithmetic mean is standard deviation. It is standard both because it is standardized for all values of n, and it is very useful, both practically and mathematically. Standard deviation is the most useful measure of dispersion, as it uses all the values in the calculation. Standard deviation and the variance. To calculate standard deviation, calculate first mean bar. Now calculate deviation of each data from mean x bar, that is dx, equals x bar minus x, and square it, dx squared. The mean of all deviations square is known as the variance. The variance equals 1 divided by n times sum of sigma dx squared. Standard deviation is square root of the variance. Standard deviation formula is sigma equals square root sum of sigma x bar minus x squared divided by n. Standard deviation is represented by sigma. Standard deviation calculation. Using same data table of earning, we used it to calculate mean deviation. In second column we write the deviation from the mean. That is 20, 15, 5, 15, 25. Total sum of deviation is 80. Remember average mean deviation we calculated was 80 divided by 5 is equal to 16. In second column we square the each deviation. That square of 20 is 400. So next is 225, 25, 225 and 625. Sum of deviation square is 1500. Standard deviation formula is sigma equals square root sum of sigma x bar minus x squared divided by n. Sigma equals square root 1500 divided by 5 equals square root 300 equals 17.3. To calculate standard deviation from a grouped frequency distribution, standard deviation formula is sigma equals square root sum of sigma f times x bar minus x squared divided by sum of sigma f times class interval. Sigma equals square root sum of sigma f times dx squared divided by sum of sigma f times class interval, where dx equals x bar minus x and square of it dx squared. We explain it further using an example of overtime given to 50 employee from 20 to 80, which was distributed in group of 10, starting from 20 to 30, 30 to 40 and so on. In this data table we assumed mean x bar equals 55 and sum of frequency is 50. We write down midpoint of each group as 25, 35, 45, 55, 65, and 75. In next column we write product of midpoint times frequency. 50, 175, 405, 935, 585, 600. The total of all these product of MP times F equals 2750. From this we calculate mean x bar, that is 2750 divided by 50 is equal to 55. Now in next column is deviation from mean 55, that is minus 30, minus 20, minus 10, 0, 10, 20. In next we write f time dx. Minus 60, minus 100, minus 90, 0, 90 and 160. In next is f times dx square. That 1800, 2000, 900, 0, 900 and 3200. Note sigma f times dx equals 0 because assumed mean 55 is same as actual mean. Sum of sigma f times dx squared equals 8,800. Standard deviation formula is sigma equals square root sum of sigma f times x bar minus x squared divided by sum of sigma f. Sigma equals square root 8,800 divided by 50 equals square root 176 is equal to 13.26. To calculate standard deviation from a grouped frequency distribution with assumed mean x, then dx equals x minus assumed mean x, and square of it, dx squared. Standard deviation formula is sigma equals square root sum of sigma f times dx squared divided by sum of frequencies sigma f minus sigma f times dx divided by sigma f whole squared times class interval. In this data table, we assume mean x equals 37.5, and sum of frequency is 100. We write down next column deviation of class from assumed mean class. -3, -2, -1, 0, 1, and 2. Next, we calculate f times dx. That is -33, -30, -17, 0, 30, and 20. Now f times dx squared. 99, 60, 17, 0, 30, 40. Sum of f times d equals -30. And sum of f times dx squared equals 246. From this we calculate mean x bar, that is 37.5 minus 30 divided by 100 times class interval 5 is equal to 36. Standard deviation formula is sigma equals square root sum of sigma f times dx squared divided by sum of frequencies sigma f minus sigma f times dx divided by sigma f whole squared times class interval. Sigma equals square root 246 divided by 100 minus 30 divided by 100 whole squared times class interval. Sigma equals square root 2.46 minus 0.09 times 5. Sigma equals square root 2.37 times 5 is equal to 1.539 times 5 equals 7.97. Before we conclude, we take one more example for calculating standard deviation from assumed mean method. Try calculating yourself and verify your mean and standard deviation given here. You may pause video now, else continue to note down calculations. Thank you very much for watching this video on statistics. Hope you enjoyed the presentation. Please continue to watch our other videos and subscribe the channel.